Okay guys, so today's video is over multiplying and dividing radicals. So far we've learned how to simplify radicals. We've learned what to do when we're adding and subtracting them. Now we're going to learn a new set of rules for when we are multiplying and dividing with radicals. So let's get started. Here's our first problem. Square root of 3 times the square root of 15. When we are multiplying, they do not have to be like terms, okay? That's only when we're adding and subtracting. So when I multiply, you multiply just like they didn't have a square root symbol above them. So 3 times 15 gives me 45. Now I can't leave that as my answer. I have to simplify it. 45 is 9 times 5. 9's my perfect square. So that leaves me 3 square roots of 5. That's what you get when you multiply those two radicals together. Let's look at the next one. 2 square roots of 7 squared. That means 2 square roots of 7 times 2 square roots of 7. What do? You multiply what's outside the square roots together, and you multiply what's inside the square roots together. So 2 times 2 gives me 4. When I multiply the insides, 7 times 7 gives me 49. Now I simplify. 49 is a perfect square. What's the square root of 49? That's 7. So I'm going to bring a 7 out front. But I already have a 4 out there. So now I have 7 times 4, which is 28. All right, let's look at this one. We multiply what's outside the square roots together, multiply what's inside the square roots together. Outside this square root is a 1. You don't have to write it, but if it helps you, go ahead. So I'm going to multiply 3 times 1 to give me 3. Inside the square root, I multiply 5t times 40t. 5 times 40 gives me 200. T times t is t squared. Now let's simplify this a little bit. I have a 3 on the outside, 200. What perfect square multiplies to give us 200? That's 100 times 2. Yes, 25 times 8 is 200, but 25 is not the largest perfect square. So remember that we want the largest one. So I have 100 times 2, and then I have my t squared. Now I'm going to circle what my perfect squares are. That's 100 and t squared. Now I can simplify those. I can take the square root. The square root of 100 is 10. So a 10 is going to move out front with the 3. The square root of t squared is t, so it moves out front. And what do I have left on the inside? Just a 2. Clean that up a little bit. 3 times 10 is 30t. And then I have the square root of 2. How does that make sense? Pretty good? Okay. That's the only example on that page. Next one. Oh boy. Here we have some foiling to do. We have two binomials being multiplied together. So I need to FOIL these things. We can do it. 2 times 7, the first terms. 2 times 7 gives me 14. Now I multiply the outside terms. 2 times the square root of 5. That's just 2 on the outside. There's a square root of 5 inside the square root. So that's what you get when you multiply 2 times the square root of 5. Now I multiply the insides. What is the number outside the square roots? It's just a 7. It's this 7 times this 1. But it's a negative because this subtraction sign there. So I have minus 7 square roots of 5. And then multiply your last terms together. Negative square root of 5 times positive square root of 5. That gives me negative square root of 25. Remember to multiply inside the square roots, what's inside the square root together. Now let's clean it up. I can't simplify 14 anymore. 2 square roots of 5 cannot be simplified anymore because 5's a prime number. 7 square roots of 5 can't be simplified anymore, but this can. The square root of 25. 25 is a perfect square, so that gives me 5. Now let's combine what like terms we can. 14 can combine with the negative 5. 14 minus 5 gives me 9. 2 square roots of 5 minus 7 square roots of 5. Here we're pulling in our adding and subtracting rules. Those have the same number under the square root symbol, so I combine their coefficients. 2 minus 7 is negative 5 square root of 5. Remember to keep what's inside the square root the same. All right. Next one. Here I don't have to FOIL because I don't have a binomial times a binomial. I just have the square root of 6 on the outside, so I just have to distribute it. Square root of 6 times the square root of 2. Remember, they do not have to be the same when we're multiplying, so I get the square root of 12 minus, what do I get when I multiply the insides of the next two together? 6 times 3t, 18t. Square root of 12, how do I simplify that? That's 4 times 3. The square root of 4 is 2. So 2 square roots of 3. How do I simplify the square root of 18t? That's 9 times 2t. Square root of 9 is 3. So minus 3 on the outside and a 2t on the inside. Are those like terms? No. So that is as simplified as your answer can get. All right. Here is a new concept for us. This is dividing with square roots. We haven't done that yet. Dividing with square roots. You are not ever allowed to have a square root symbol in the bottom of your fraction. Can't ever, ever, ever have it. You have to simplify that and do something to get rid of the square root in the bottom of a fraction. So to do that, I want you to think, what can we multiply the square root of 5 by so that we no longer have a square root in the denominator? Jonathan, who's listening to my live recording, says that I should multiply the numerator and the denominator by the square root of 5. Now, why would we do that? Because the square root of 5 times the square root of 5 is equal to the square root of 25. Well, what is the square root of 25? Our goal was to get that number to be a perfect square, and it is now. So now I just have a 5 in the denominator. You're allowed to have numbers in the denominator, just not numbers under square root signs. Now I need to take care of my numerator. Square root of 3 times the square root of 5 is the square root of 15. Can we simplify that any? Is that a number that can be simplified? Is there any perfect square that is a factor of 15? The answer is no. So my answer to this problem is the square root of 15 divided by 5. Let's try the next one. I need to think, how can I get rid of that square root symbol? The easiest thing to do is to simplify the square root of 32b first before you try and get rid of that square root symbol. So I'm going to leave the square root of 5 the way it is. It can't be simplified anymore. But let's simplify the square root of 32b. What perfect square goes into 32? Well, we have 16 times 2b. 16 is a perfect square, so I circle that, and I end up with the square root of 5 in the top, and then 4 square roots of 2b on the bottom. Now, I have to get rid of that square root of 2b. Okay, you can't have it. So what would we need to multiply by to get rid of the square root of 2b? The square root of 2b. If I multiplied the numerator and the denominator, sorry, that's really hard to see. I'm going to write it over here just to make sure you can see that. I have the square root of 5 divided by the 4 square roots of 2b. I'm going to multiply the numerator by the square root of 2b and the denominator. Because all we're doing here, guys, is multiplying by the number 1. Because the square root of 2b divided by the square root of 2b is 1. If you multiply any number by 1, you're not changing its value at all. So I am not doing anything that's breaking a rule or doing anything I'm not supposed to. I'm just multiplying this already given fraction here by a factor of 1. Now, when I do this multiplication, let's see what we get. I have square root of 5 times the square root of 2b. That gives me the square root of 10b. And in the bottom, I have this 4 on the outside and nothing on the outside here, so I get 4. And then on the inside, 2 times 2 gives me 4. B times b gives me b squared. Now I can simplify that, right? So I have the square root of 10b on the top, 4 square roots of 4b squared. What does that simplify to? Square root of 10b can't simplify any. 4b squared. 4 is a perfect square. B squared is a perfect square. So we circle those. The square root of 4 is 2. So it moves out here. The square root of b squared is b. So a b is going to move out. So let's see what we have now. We have none of this is left anymore. I have 4 times 2, which is 8b. Now I no longer have a square root in the denominator, which was my goal of all this, was to get rid of the square root that I started with. So that's kind of a longer problem, getting rid of the square root in the bottom of a fraction. Okay, let's see if we have maybe 1 or 2 more. The diagram shows the dimensions of a dining table. With a leaf in place, the table expands to seat 8 people. Find the area of the table. Okay, so if I want to find area, I just multiply length times width. So I have 28 square roots of 10 times 8 square roots of 6. Let's do the multiplication. 28 times 8. What does that give me? All right, 224. Let's double check that. Sure enough. Okay, next one. Square root of 10 times the square root of 6, that gives me 60. Now I need to simplify the square root of 60 a little bit. What perfect square multiplies to give us 60? Okay, so this one simplifies to 4 square roots of 4 times 15. So I have 224 on the outside. My 4 is the perfect square, so when I take that out, I'm bringing out a 2 because the square root of 4 is 2. You're not bringing out a 4. You're bringing out the square root of 4, which is 2. 2 times 224 is 448 square roots of 15. And then I should label this inches squared since I just found area. Okay, I think that'll be it for tonight. I'll see you later.